So basically, if you take any driver, so it's already there are a number of things are there. Like if you take a driver with 10 functions, so we can use any one of the function in the particular driver. So remaining nine functions may not be used at this moment for this particular application. Low memory uses and the ground out control. Perfect, sir. Karthik RPEC. That's correctly answered, sir. So thing here is if a driver, predefined driver, it is consisting of 10 functions. So for our application, we may use only one to two functions. Rest of the eight functions may not be used for the particular application. But in the driver, it is consisting of all the functions. So we need to integrate the particular driver function in our main stream. So the size of the file will be increased. So it is eventually leads to the inefficiency in terms of memory organizing. So thing here is we should go for a bare metal programming, and completely we can develop each and every line of code by our own. That's the first thing. Second thing, we don't need to use unnecessary user functions in the drivers. So this particular bare metal programming is very helpful for the freshers, those who want to develop any project. If they want to technically sounded, it's my suggestion is they just want to go for a bare metal programming. If the experts, they can use the drivers. So bare metal coding will help the students to develop bare metal like driver development, which is having a huge demand in the market in nowadays. So if the student is able to develop the bare metal coding and drivers, so those profiles are having high weightage. So drivers can be used by anyone else. Anyone else can be simply used whatever the inside the driver. Anyone can simply use the predefined functions. But the development of the functions using bare metal is having high advantage, high weightage. So if someone want to think about whether they want to go for a ready-made available drivers and functions, or else they want to develop the functions. So as a student perspective, as a tech aspect, it's always better to go with the bare metal programming. If the company is well established, if the employees like student or employees well experienced, then they can go for a driver already available drivers. They don't need to spend too much time on the driver development since they are already having experience. For the freshers and the students, bare metal programming is always preferable. All the industries are looking for those who are able to develop the drivers for their organization using bare metal. These were the industry requirement. So without further delay, I would like to go for a bare metal programming. So thing here is we are dealing with LPC 1768, which is a ARM Cortex M3 family. So the controller is made by NXP. The manufacturer is NXP Semiconductors, and the core logic built by ARM company. So now we will discuss about how can we develop that particular bare metal programming. Okay. So if you are having any notes, you can feel free to interact. So one way teaching is like not preferable. So if you are having any notes, you can stop at any moment so that you can learn a lot. Thing here is by today or tomorrow, like tomorrow or Monday, we are going to close these particular FDP sessions. So if you are able to learn the basic stuff, it will be helpful for your students. So that is what the main motto behind this particular thing. And one more thing, every Sunday or alternate Sunday, our company is conducting career catalyst talks and masterclass from different industry people. This Sunday, I guess we are conducting one talk from IIT Madras. IIT Madras alumni student, and who is having 4 to 5 years of industry experience in VLSI domain. So it will be useful for the students, those who want to excel in their particular career in the embedded or VLSI domain. His insights, he is having gate score around 522, and he is working as a VLSI design engineer. I'm not sure, but he's a good profile, having 4 to 5 years of experience. Yes, sure. Our team will share shortly in the FDP groups, and he's having 4 to 5 years of industry experience. At the same time, he's a IIT Madras alumni. So his insights is truly helpful for your students. You can also join in the particular session. So in this upcoming Sunday, one person from Qualcomm for embedded role, and later on one person from AMD. So these are lecture of courses, sequence of activities, series of talks are there on every Sunday, alternate Sunday. So you can engage your students or you can join. So which is really helpful for you guys as well. Like what exactly industries are looking for, what exactly their expectations. So where is the gap between industry and academia? You can focus on these particular aspects so that you will have a chance to enhance your curriculum. And we can also open for curriculum collaboration, curriculum enhancement. So we are a group of people from IIT, myself from BITS Pilani, So we are plenty of good profiles in our organization, and we have a good collaboration with 30 plus industries, core EC and triple industries. So you can collaborate with us so that you will have a better advantage. So we are always focusing on better future, better education only give the better future. So that is what our motto. So okay, chalo, we'll go for bare metal programming. How can we do this particular bare metal programming? So these were the key IDE. Okay, this platform is useful to develop the coding. Like we can go for a ARM Cortex M1, M2, M3, M13. We can like it will support huge number of controllers, huge number of families. So this platform we called as the software we called as Scale IDE, Scale IDE, and these were the environment. Okay, so in detailed documents our team will share shortly like how can you install this particular Scale IDE and how to do this particular thing. So as a part of FDP, I just want to explain how can we do this particular thing. Okay, I guess my screen is visible for you guys. These were the simple coding for LED on and off. So let me explain the code first. Then we will go through like how can we develop this particular code. Okay, has include LPC1768.h5. So that stands for we are dealing with ARM Cortex M3. We are going for a LPC1768, which is a ARM Cortex M3 family. So we are including that particular header file. So that header file is LPC17xx.h5. This are we are going to include. I will explain like why we are including that particular header file. I will slowly explain. Thereafter, int main. We are starting main function here, and the main function is terminated at line 18. Okay. So first, for any IO pin, IO stands for input and output. Input is switch and output is LED. So for any IO pin, we should define the direction. So this particular line of code will go for a direction setting, whether that is input or output. Okay, you can keep this particular line as a comment. So first of all, there are 4 steps for any peripheral protocol configuration. First is power up the peripheral. So here we are using LPC pin con. Out of LPC pin con, we are using pin selection 3. In pin selection 3, we are going to write 6. 6 stands for, like, let me go for 6. Decimal 6 stands for binary 0, 1, 1, 0. Are you getting? So here we are keeping 1, 1, and 3 stands for 1, 1. So on the 6th position, let me explain. Like nothing to worry. I will go in detail. These are the basic intro. Tomorrow also I will discuss the same thing. So 6 positions left side shifting. By shifting left 6 times left side, we are keeping 3. 3 stands for. 3 stands for. We are keeping 1, 1. We are moving 6 times left side, and we are going to keep 1, 1. You just go through this particular thing. I will explain. And once the power up, we are going to set the direction. The register is FIO direction. So the port is LPC GPIO1, and we are going to keep 1. Here we are keeping 3. 3 stands for 1, 1. We are keeping 1, 1, 6 positions left side. Like on 6th position, we are going to keep 1, and 7th position, we are going to keep 1. And in this case, we are going to keep 1 on the 19th position. 19th position left side shifting, and we are going to press 1. Okay, so in the direction register. Coming to while, this will be used to set the direction as the output. And later we need to on the LED. For on the LED, there is a function called register called FIO set. And FIO set 19 positions left shifting, and we are keeping 1 there. And we are going to wait for some time, and thereafter we are passing a command to off the LED. To off the LED, FIO clear. FIO stands for fast input and output clear. So again 19 positions left side shifting, and we are going to keep 1 there. So these were the simple code for LED on and off. Is that clear for everyone? Now I will explain like how you did this particular thing, what is the importance of this particular bare metal, and what are the steps involved. So let me explain each and everything clearly. So in the initial phase, we are included lpc17xx.h file, right? So we will go for header file. So this was the header file. So coming to lpc1768. So these were the lpc1768 user manual. Our team will share all the stuff in the group itself. So this is the chapter meant for GPIO, general purpose and input and output. Okay. So for basic configuration, there are 4 steps. One is power. Second one is pin selection. And third one is wake up pins. So by default, some of the pins will be in sleep mode. Some of the pins are default in wake up mode. So we need to take care to wake up the pins which are in sleep mode, because it's not recommended to keep all the pins in wake up mode, because most of the embedded systems are in the site, in the field. So even 1 milliampere current also makes the huge difference in the real time. So what are the pins are not required, we should keep all the pins in the sleep mode. What are the pins, whenever they are required, we just make those pins in the wake up mode. That's what the concept of wake up and sleep mode. And the fourth one is interrupt. Whenever there is action is required, we will generate the interrupt, then the action will take place, and again it will go back to the original main loop, main routine. Okay, so this is what one more story behind interrupts, wake ups. Okay, so now we'll see about what about this particular GPIO. So while we are going for a GPIO, GPIO stands for general purpose input and output. There are few registers. Those registers are FIO direction. FIO stands for fast input output. DIR stands for direction. Fast input output direction register. And like for this session, I will only discuss 3 registers. And the next one is FIO SC set. FIO set means fast input output set. And the next register is FIO clear, fast input output clear. To clear any particular bit, we will use FIO clear register. To set any bit, we are going to use FIO set register. To set the direction of any pin, we will use FIO direction register. These 3 registers we are going to discuss today and tomorrow. See here, like it's a big topic. Let me break down each and everything today and tomorrow. If it is like I understand, that's fine, or else I will take one more session on Sunday. So which is a initial topic. This is the base for all the topics that might be GPIO, timers, VR, I2C, SPA, blah blah blah. What are the things deal with this particular bare metal coding? Today and tomorrow session is very important. Like we are going to discuss about the basics. So you may understand, may not understand, but that's fine. My expectation is please try to interact if you are having any doubts. So coming to FIO direction register, we can use this particular direction register to set the pin either input or output. Since IO stands for input and output. So using FIO direction register, we can make any specific pin for input or output. If you are able to place 0 on the particular pin, it will be work as input. If you are going to place 1, it will be work as output. Okay, you just remember this particular thing. So FIO direction, on keeping 0 on FIO direction register, it will be set direction as the particular pin as input. If you are going to place 1, it will be work out as output. So that IO pin will be worked as output. If we place 0 on the particular IO pin, it will be work for input. So these were the story behind FIO direction. Now we see about FIO set. If you are placing 0, the output won't be changed, unchanged on FIO set register. If you place 0, the output won't be changed. If you are going to place 1, the output will be high. The output will be set. To get the set function, we need to place 1. If you are going to place 0, that doesn't mean it will clear. Try to listen. So if you are going to place 1 on FIO set, it will be working as set function. If you place 0, it won't mean it is going to clear. It won't be unchanged. Okay. Now we will discuss about FIO clear. So to work FIO clear, if you are going to place 0, it doesn't mean it will be working as clear. It won't be unchanged. It won't be changed. If you are going to place 1 on FIO clear register, it will clear the pin. It will get the functionality. That functionality is clear functionality. So let me explain each and everything again. So there are 3 registers. One is FIO direction register. So on FIO direction register, if you place 0, then that particular pin work as input. So for IO, same pin will be worked as input and output. So if you place 0, then that particular pin will be worked as input. So if you place 1, that particular pin will be worked as output. Let me go back to the code. See here, we are placing 1 on 19th position. 19th position. On 19th position, we are keeping 19 positions left side shifting. I will explain this particular shifting concept. 19 positions left side shifting, and we are placing 1. So on FIO direction register, this register is consisting of 32-bit register. All ARM Cortex M3 LPC 1768 controllers are 32-bit microcontrollers. So each register in the particular controller is having 32 bits. Okay. So out of 32 bits, my focus is 19th position. So on 19th position, we are placing 1. Okay. 1 left shifting of 19 positions. So that particular pin will be worked as output. Is that clear? Now, same thing. To get the LED on, we are using FIO set. Again, we are keeping 1 by shifting 19 positions left side. This is left side, left shifting. 19 positions left shifting and placing 1. Then we will get the FIO set functionality. Same thing, we are waiting for some time, and we are going to clear that particular pin. FIO clear 1 left shifting of 19 times. So these were the stuff. Okay. Now we will see. We saw these were the user manual. On user manual, there are 5 registers: FIO direction register, FIO mask register, FIO pin register, FIO set register, and FIO clear registers. So don't think about FIO mask and FIO pin. As of now, we will only focusing on FIO direction, FIO set, and FIO clear. These are the registers we are going to discuss. So coming to FIO direction register, by placing 0, that pin will be worked for input. By placing 1, it will be worked as output. For LED, we are keeping 1 on the FIO direction register. And coming to the set, to get that set functionality, we are going to place 1. Then it will work as the set. If you place 0 on set register, it won't be changed, unchanged. Same thing for clear. To get the clear functionality, we need to place 1 so that the particular pin will be cleared. That will be load. If you are going to place 0, that doesn't mean we are clearing. If you place 0, it's unchanged. So these are the 3 registers. So how these 3 registers are packed? How these 3 registers are packed on the header file? Now we will see. These were the header file. Let me go there. LPC GPIO topic. So these were the structure. What are the highlighted part here? That is structure meant for general purpose input and output. What are the registers we saw on the user manual? These were the user manual, right? So there are 5 registers. Those registers are: FIO direction is 1 register, FIO mask is 2nd register, FIO pin is the 3rd register. Each register is consisting of 32 bits. FIO set is the 4th register, and FIO clear is the 5th register. So to get this particular send function, we need to place 1. To get the clear function, we need to place 1. And coming to IO, we need to place 1. To work as output, we need to place 0 to get the input functionality. So these are the 5 registers. So all those 5 registers will be mentioned in the header file in a structure. That structure name is, you just see here, LPC GPIO type def. These were the structure. You just keep type def for a while. You just keep type def aside. So the structure name is LPC GPIO. This is the structure name. Now we will see the members. So if you see clear, so this clear is the member of this particular LPC GPIO structure. In this particular LPC GPIO structure, there are members called FIO clear. This is 1 member. FIO set is 1 member. FIO pin is 1 member. FIO mask is 1 member. FIO direction is 1 member. There are 5 registers in the user manual. Those are FIO direction, FIO mask, FIO pin, FIO set, FIO clear. These are the 5 registers. So all those 5 registers are part of LPC GPIO structure. In this structure, they are keeping FIO clear, FIO set, FIO pin, FIO mask, and FIO direction. These 5 registers, listen, these 5 registers as members in LPC GPIO structures. So we are going to access those members. These were the code. LPC. We just forget about GP11. We just forget about this particular thing. I will explain tomorrow. So LPC GPIO. This is the structure name. Out of that particular structure, the members are FIO direction, FIO set, FIO clear. These are the 3 members. These 3 registers are members in LPC GPIO structure. So we are going to access LPC GPIO from the structure. We are going to access using forward arrow. LPC GPIO structure, from GPIO structure, we are going to access the member FIO direction, the member FIO set, the member FIO clear. These are the three members of this particular structure we are going to access. Now we need to place one right to get the direction as output. We need to keep one to get the set functionality to, and we need to keep one to get the clear functionality. Now we will see how the bits manipulation is taking place. Okay. So now we will see about bit manipulation. So now we are going to discuss about mastering the bit manipulation, how the bits are manipulating. So in this particular presentation, we are going to discuss about from a single bit to single bit full control. Like how can we control each and every bit in a register? Register is size of 32 bit. How can we control all the bits in the register? Okay. So see here. So there are 8 bits. Let us assume there is a 8 bits. I want to place one, like this is the pattern 1 0 already in the byte of the data, 8 bits of data. There is already data like 1 0 1 0 1 1 0 0. These are the data. So 7th position is MSB and 0th position is MSB. Wherever there is a 1, that is logic high. Wherever there is 0, logic low. Now we will discuss about 5 major functionality, 5 bitwise operations for any embedded engineer role. These particular questions, the students for sure they will get it. Like what are the bitwise operations? AND operation, OR operation, NOT operation, left shifting, right shifting, digital electronics. All the embedded companies major focusing on digital electronics. Why they are asking is we need to manipulate the data in the controller. To manipulate the data, students should know minimum like how bitwise AND operation works, bitwise OR operation works, bitwise NOT operation, bitwise left shifting, right shifting. The basic stuff, bitwise operations. Anyone can minimum expectation from the student. So now we will discuss how these particular topics will be helpful for the students in the industry. Now, if we take 2 bits 0 0 0 1 1 0 1 1, if we are getting the ORing operation, we are getting 1 if both the bits are 1. Okay, so these are the existing data 1 0 1 0 1 1 1 0 1 0 1 0 1 0 1 0. These are the existing data. We just want to manipulate the first 4 bits. I just want to place 1. So end operation is a masking. Masking stands for we will extract the existing bits to get the, like in the controller out of 32 bits. If we want to extract any bits, we will simply apply end operation. So I just want to extract 4th bit, 3rd bit, 2nd bit, like 0th position bit, 1st position bit, 2nd position, 3rd position. If I want to extract these particular 4 bits, I will apply 1 1 1 1 and apply end operation, so that I will extract those bits. If you see here in the 0th position, there is 0 0 and with 1 we will get 0. So this one only extracting here, and 1 and with 1 1, and 0 and with 1 0, and 1 and with 1 1. So wherever we are expecting extraction of the bits, we need to do end operation with 1. So I just want to extract whatever the bits are there. I just want to extract. So I am applying 1 1 1 1 1 end operation. So we are extracting. Second thing, OR operation. So I just want to manipulate whatever the values I want. So there is 0 0 1 0 1 0, 4 zeros are there. I just want to keep whatever the values I want. So in the 4th position I want to place 1, and 0th position I want to place 0, and 1st position I want to place 1. 2nd place I want to place 0, and 3rd place I want to place 1. Here in the end operation I just want to extract whatever the bits are there. In case of OR, I just want to place whatever the values I want to place. So I just want to place 0 1 0 and 1. This is what the thing I want to place. So we simply apply OR operation. So 0 and with 0 0, and 0 and with 0 OR with 1 1, 0 OR with 0 0, 0 0 OR with 1 1. So whatever the value I want to place, I want to place 1 0 1 0. So finally I am placing those values 1 0 1 0. So if you want to place any value, we can go for a OR operation. If I want to extract any bits, I need to do AND operation. Let me come back to the coding again. So listen, wherever value I want to place, either 0 or 1, wherever I want to place 1 or 0, we will go for a OR operation. As a time constraint, I just want to summarize the thing in detail. There is a lot of story behind this particular stuff. So as a time constraint, I just want to give a conclusion notes. Okay, that doesn't mean this is the stuff. There is a lot of things. Okay, offline sessions are more preferable. We are yearly once we are conducting free FDP in Andhra region. So this year we are planning in the month of June. So on the free FDP, you can visit our industry. You can be part of that particular FDP for a 1 week. So there you will have a plenty of opportunity to explore all those stuff. Okay, wherever I want to place 1 and 0, I am using 1 R operation. So let me come back to the presentation coding again. So here I want to place 1. So that's why I'm applying R operation here. R operation here. So I want to place 1. Or else if I want to place 0 also, we should go for a R operation. Okay. Let me come back to the bits manipulation. These are the AND and R. AND simply to manipulate the bits, or else to extract the bits. Or simply if you want to place 1 or 0, you can simply go for a R operation. So inverted logic, 1s and 0s will be done. And coming to the left shift and right shift. First we will discuss about left shift. In our code, we see 1 left shifting of 19. What exactly this stands for? In a register, there are group of 32 bits are there. This is 1 byte of data. Okay. So on third position, this is the 0th position. This is the first position, second position, third position. I just want to place 1 on the third position. I just want to place 1 on the third position. So 1 left shifting of 3 times. How many positions we need to shift? 3 positions. These are the 0th position and first position, second position and third position. So we are placing 1 here on the LSB position and 3 times shifting. Like 1 shifting, 3 times shift to the third position, and there we are going to apply R operation. See here. This is what exactly we are going to set a bit. So that is the register. We are using the register name FIO direction, FIO set, FIO clear. Those are the registers we are using. And how many positions? In our code, we are going for a 19 position shifting and 1 left shifting. Like how exact it's happening. In this particular example, we are going for a 3 positions left shifting. So 1 left shifting of 3 times. So how exact it's happening? So there is a 0 on the third position. These were the bit position. These were the stage 1. Starting original registers. So we can take FIO direction, FIO set, FIO clear, any register. So there is already data 10, 10, 00, 0, 10. This is already there. So on third position there might be a 0 or 1. I just want to place 1. There might be a 0 or 1, but I want to place 1. So how can I do that? 1 left shifting of 3 times. Okay. So these what 0th position, first position, and second position. And for third position, we are shifting. So already there is a 0. Already there is a 0. 0 R. We are applying R operation. 0 R with 1, what we will get? 0 R with 1, what we will get? We will get 1. 0 R with 1, or else 1 R with 0, we are going to get 1. Right? That is the stuff. We are going to move 0 R with 1, we will get the 1 here. These were the example. Already 10, 10, 0, 0, 0, 10. This is the data. So we are going to R with 0, 0, 0, 0, 1, 0, 0, 0. So 0, 0, R in 0. 1, 0, R in 1. So the rest of the bits won't be manipulated. If you see the original data, these were the final data. So no other bit won't be changed. Here 1, we are getting 1. Here 0, we are getting 0. Here 1, we are getting 1. Here 0, we are getting 0. Here 0, but we are getting 1. Intentionally, we change. Forcefully, we change the third position as 1. So second position 0, 0. First position 1 remains 1. And 0th position 0 remains 0. So this is how the code works. Let me go back to the code again. 1 left shifting of 19 positions. So on the 19th position, there might be a 0 or 1. So if there is a 0, 0 R with 1, we will get 1. If there is a 1 already there, 1 R with 1, we are getting 1. 1 R with 1, 1. R with 1, we are getting 1 only. So this is how we did the code. Is that clear for everyone? So these were the today's session. So I can extend the session, but as this is the new topic, you can't get everything in a single day, single session. So I request you guys to please go through this particular stuff. Simple thing, like this particular LPC 1768 for GPO topic, there are 5 registers. Those are, let me summarize today's session. FIO direction register, FIO mask register, FIO pin register, FIO set, FIO clear. These are the 5 registers. So how FIO direction, in this particular topic, we are only dealing about FIO direction, FIO set, and FIO clear. So how FIO direction will work? So when we are keeping 0, it will be work for input. That IO pin will be worked as input. When we are placing 1, it will be worked as output. For LED, we should place 1. So coming to set register, if you place 0, it won't be changed. It remains unchanged. If you are going to place 1, then we will get the set function. That particular bit will be high. Coming to clear, if you place 0, the output will be unchanged. It remains unchanged. If you want to clear any bit, if you want to make it low, we should use FIO clear register and we should place 1 on the desired position. These are the 3 topics. So now I will explain how these particular 3 registers are structured in the header file. So all the registers, FIO direction register, FIO mask register, FIO pin register, FIO set register, and FIO clear register. All those 5 registers are a part of LPC GPIO structure. All those 5 registers as members in a LPC GPIO structure. So now we are going to classify like LPC GPIO from that particular structure. We are going to access, this arrow will access that particular members in any structure. So the members are FIO direction register, FIO set register, FIO clear register. We want to place 19th position as 1. 19th position for output. Okay, so that's why one left shifting of 19 positions. Once one reaching 19th position, we are doing R operation. In the 19th position, there might be a 0 or 1. On the 19th position, there might be a 0 or 1. If there is a 0, we are sending 1 on those many positions. We are doing R operation. So finally, we are getting 1. If already there is a 1. We are passing 1 and we are applying R operation. So finally we are getting 1 only. So intentionally, if there is a 0 or 1, by doing left shifting and by placing 1 and doing R, we will forcefully write 1 on that particular position. Okay. So that is about this particular thing. Now we will see about simulation. Like this what continuous LED on and off. Okay. Now I will showcase like how can we get the simulations. So these were the debugging. Okay. I'm just running and I just want to see the waveforms. So I will go for logic analyzer. So are you able to see the waveforms? So continuously set and clear, set and clear, set and clear. So that LED will be toggled on and off. Tomorrow's session I will come up with the hardware and I will explain how this particular functionality will work. And request you guys to please come up with some basic study about user manual and header file and bare metal coding. This is really helpful for you guys as well if you want to move for any industry. Thing it is, if you want to move for any industry, so this particular stuff is enough. Like how can we write the bare metal coding using structures and unions? If you are able to understand this particular header file, this header file is full of structures and unions. And shifting coding, it's all about placing 1 or 0. Here we are placing 1. Here we are placing 0. How can we place 1? How can we place 0? I will discuss. Already we discussed about how can we place 1 by shifting those many positions and by doing R operation. Tomorrow we are going to discuss about how can we place 0 on the desired position and how can we read the data. So this is what tomorrow session. So hopefully you understand the topics. So now I will be open for doubts clarification. So if you are having any doubts, please feel free to express your doubts. So I'm happy to clarify your doubts. So any doubts? So you don't need to worry. Tomorrow I will explain each and every topic in clear. So any doubts, dear faculty members? So assignment submission deadline. So yeah, can you answer the question? So when we do the assignment closing date, and kindly share the brochures through group. Yeah, sure, sir. Our team will do the mail about career talks. So career talks are very, very helpful. Like people from IIT Bombay, IIT Madras, and those who are having 6 years, 8 years of experience already in our YouTube channel, Sans Academy channel. There are plenty of career catalyst talks and master classes. So those people are from different industries. And from for 2026 also we launched multiple series of career talks. It will be helpful for your students. So please share the information with the students. So any other doubts, dear faculty members? Dear faculty members, if you want to move to any industry, please contact our team. We will help you guys to either upskilling for your academy aspect, or else if you want to move to any industry, our team will help you out. Like it's a completely non-commercial activity under SSIT and Semiconductor. Every year we are educating more number of faculty. So here is the career catalyst talk 11 for this particular year. So he is a all India gate score like 522. He's currently working as like digital IC design at Reed Semiconductors, and he is from IIT Madras. Storia, please.
Dear faculty,
please.
Dear faculty, this is our career talk 11. So this is all about a building career in VLSI and opportunities. We are going to discuss opportunities, skills, and roadmap regarding VLSI careers for engineering students. So the schedule is this Sunday, coming Sunday, 1st February, evening 6 p.m. So we'll share the entire information in our FDP groups. So kindly requesting you to share the information with your students so that they will get benefited. They will earn. So ECE students basically get like idea about the core opportunities. In VLSA, what are the opportunities available in the market? So all of you know, VLSA is the booming industry nowadays. So this career guidance session will helpful for you. Okay, so kindly share the information with your students. We'll share the entire information in the group. So that's it for today, guys. Yeah, if you don't have any doubts regarding assignment link, tomorrow we'll share the assignment submission link to your mail ID in the WhatsApp group. So please submit the assignment. So that's it for today, guys. Thank you. If you don't have any doubts, we'll wind up the session, wrap the session here. So that's it for today. Have a nice day. Bye-bye. Thank you.